Beta, the concept under discussion is KPC. KPC is partition coefficient. Partition coefficient. Okay. So before going to the definition of KPC, we need to know what KPC is. Beta, let me give you an example. Suppose we have water here in a beaker, and suppose this water contains 0.5 grams of a solute, okay, of a dissolved solute, of a dissolved solute X, okay. And let us say this X decomposes on heat. Suppose this is the situation for X, that X decomposes on heat. So how can we extract X from water? X decomposes on heat. So if X decomposes on heat, so one thing is sure that we cannot heat this solution to extract X, because in that case, X will be decomposed. Right, beta?
Yes, sir.
So now, beta, the extraction which does not involve any heat is named as solvent extraction. We will extract this X through this method, through solvent extraction. A solvent extraction does not involve heat. But what solvent extraction is, beta? Solvent extraction is this method K in water where X is dissolved. Okay, this is water, and where 0.50 gram X is dissolved, we will choose another solvent, and that solvent should be immiscible with water. We will select a solvent that is not miscible with water, and the X, which is soluble in water, should be soluble in that solvent as well. You got my point? So usually organic solvents are immiscible with water, like oil and water. Oil doesn't dissolve in water. Immiscible solvents develop two layers. Okay, so let's say we can add hexane. And beta, examiner will give you the name and the quantity of the other solvent. You are not supposed to memorize the names of the solvents. So let us say hexane is added to this water, and suppose this water is 100 cm cube water. Okay, and 20 cm cube hexane is added. So hexane is organic solvent, or hexane doesn't dissolve in water, but X dissolves in water as well as in hexane. Right, Peter?
Yes, sir.
So what we did, we selected a solvent. That solvent is not miscible with original solvent. Original solvent was water. So then we will shake this solution in a container, beta. Like this is separating funnel, or a kind of container usually available in lab. So we will place both these, the entire mixture here. This is aqueous layer, the lower layer. The water is here. This is aqueous layer because water is present in this. And its volume is given 100 cm cube. And better, the other layer we added is hexane, that is 20 cm cube hexane. And better, when we will place the cap of this container, now the container is fully closed, so we will shake it. What's the purpose of shaking, beta, this mixture? Why we are shaking this mixture?
Speed up the reaction?
It's not reaction, beta. The X, which was originally dissolved in water, that X will come in contact with hexane as well when you shake it,
Okay.
right? So, some part of X will get dissolved in hexane. X was soluble in water, but now some part of X will dissolve in hexane. Suppose it is given, okay? Okay, 0.40 gram of X, this information is given. is dissolved in hexane. Originally, it was 0.50 gram of X dissolved in water. So how much X will be left behind in water, beta? What do you think?
0.1.
0.10 gram of X is left behind in water. Okay. So now basically you have two solutions. The lower layer is aqueous solution in which X is dissolved, and upper layer is organic solution in which X is dissolved. So then better you can keep a beaker here. Okay, just open this nozzle. When you open the nozzle, the water will be extracted here. Water is 100 cm cube, and that 100 cm cube water contains 0.10 gram of X. Then you will remove the beaker and you will place another beaker, beta. The other beaker may hexane will be collected. This 20 cm cube hexane will be collected, beta. And in this hexane you have 0.40 grams of X. Got it? Now the interesting part is that this hexane is volatile, but organic solvents are volatile. So hexane will evaporate without heating. So when hexane evaporates, you will be left behind with X beta. So this is how you extracted X without heating. And this entire thing is solvent extraction. Got the idea? Give it any confusion or question?
No, sir.
Acha, now what happened, beta, when we were shaking these two solutions? Okay, these two solutions we were shaking. So what happened that X distributed itself between two solvents? One solvent was hexane, the other solvent was water. So X distributed itself in two solvents. So any solute in particular solvents will always distribute itself in a particular constant ratio. Okay, this distribution of solute in two solvents will always be constant. Okay, and that constant is Kpc. Okay, or in other words, beta, in simple words, Kpc is a ratio of concentration. Like beta, X concentration in organic solvent. In organic solvent, look beta. In organic solvent, look, this upper layer is organic layer. So X is dissolved in this solvent. So X will have some concentration because solution is made there. And then concentration of X in aqueous solution, beta. I think we should say it as organic solution, okay? Concentration of X in organic solution and concentration of X in aqueous solution. This ratio will always be a constant, and that constant is Kpc. Got the idea, beta? What Kpc
No,
is?
sir. X like divides itself.
Yes, X divides itself between two immiscible solvents, and X always divides itself between the two solvents in a particular ratio in a way that the value always remains constant, and that constant is Kpc.
Okay.
Okay, and when X divides itself, you get two solutions. Both solutions have different solvents, but solute is same. Okay, so two solutions, one solution is organic solution, the other solution is aqueous solution. Both have X as solute. जी बेटा, any confusion?
No, sir.
So Kpc is for 2 mass, it is defined as it is equilibrium constant. It is equilibrium constant that represents the ratio of concentration of a solute in two immiscible solvents. In two immiscible solvents. Okay. Like this formula is also telling you the ratio of concentration of a solute. So this is how KPC is, and this is how you need to define KPC. Now, beta, how would we calculate this KPC? We have values, beta. So this KPC will be equal to, for this situation, beta, what they are saying, 0. Beta, in organic solvent, the concentration is 0.40 divided by 20. Does it make sense, beta? Concentration can be in gram per cm cube as well. Like the data is telling us from the diagram that 0.40 gram of X is dissolved in 20 cm cube hexane. You getting this, beta?
Yes, sir.
And what will be the concentration in aqueous solution?
0.1.
10 divided by 100. Okay. So KPC has no unit. Okay. So unit will be cancelled out in any ways. So that is why no need to convert the concentration into mole per dm cube. Okay. Just make sure that the unit above and unit below are same. So both units will be cancelled out. KPC has no unit. So better we can solve it like this. KPC will be equal to, this KPC will be equal to 100 into 0.40 divided by 20 into 0.10. So what value will we get, beta, from this? I think 20 is the value.
Yes, it's 20.
20 is the value. And KPC has no unit, okay? KPC has no unit. Got it?
Yes, sir.
Okay. Achha, now, beta, the next thing is that, beta, what we did here, the entire situation, I'm telling you again, what we did here, that we had water in that question above. Water was 100 cm cube, and there was 0.50 gram of X was dissolved in water originally. Achha, then what we did, we took a solvent. That solvent was immiscible with water, so we took hexane, beta. The examiner will tell you that which solvent you have to select. So 20 cm cube hexane we selected, beta. That 20 cm cube hexane was added, and then the solution was shaken. And what we found that 0.40 gram of X get dissolved in hexane and 0.10 gram of X left behind in water. And then we calculated KPC, and the KPC came out to be 20. So KPC always remains constant, okay? As long as this solute and these two solvents are there, this KPC will remain constant. Now the next thing is beta कि instead of adding this 20 cm cube hexane together in one step, instead of adding this 20 cm cube hexane together in one step, what we do beta, let us add hexane 10 cm cube in two intervals. Okay. We want to investigate that what happens that when we add the solvent in more than one intervals and we add the same amount of solvent, like we added 20 cm cube hexane and we extracted 0.40 gram of X. Now we want to try that what will happen if we add this hexane in two intervals. And in each interval, we will add 10 cm cube hexane. Interval 1. But you got that what I'm saying?
Yes.
So in interval 1, what we are doing, beta, add 10 cm cube hexane. Okay. So let us make diagram again, beta. What we had 100 cm cube water originally. and 0.50 gram of X was dissolved in this. Now we added 10 cm cube hexane. And now we will shake the mixture. Okay. So upon shaking the mixture, some of the X will be dissolved in hexane. We don't know that how much X will be dissolved in hexane. Okay. Earlier it was given 0.40 gram of hexane is dissolved. Now we don't know that how much X will dissolve in hexane. So I'm supposing a Y gram of X dissolves in hexane. So suppose if Y gram X dissolved in hexane, how much X is left behind in water? जी बेटा,
Mm.
you got my point? What I was saying?
So why would we do it in two intervals?
Better, this is, we want to check that what happens.
Oh, okay.
Just for our study, that what happens if we do not add 20 cm cube together in one step, rather we make two-step extraction.
Was there a 0.3 be there?
Better, we decided that Y gram of X dissolve in hexane. So how much is left behind in water? Won't it be 0.5 minus Y?
Yes, sir.
You got this or not this point?
Yes, sir.
Okay, now can we apply KPC on this? So KPC, concentration of X, beta, in organic divided by concentration of X in aqueous. So KPC value was 20 now. KPC remains constant. So what is the concentration in organic solvent? जी बेटा, you tell.
0.5 over 100.
No. In organic solvent, won't it be Y over 10?
Oh, yes.
Got it? You
Yes, sir.
taking the entire part, or should I repeat again the entire thing?
So I'm finding it a little confusing.
Sorry, beta.
So I'm finding it a little confusing.
Value is confusing.
No, I'm finding it a little confusing, sir.
From where, beta? From these two interval thing?
I don't get the point of KC, like KPC.
Or right from the start it was confusing?
Yes, sir.
Right from the start it was confusing.
I know, sir, yeah.
Okay, beta, let me explain again, okay? Let me discard this recording.